Okay, good morning once again. We will begin our lecture. Okay. So today we are going to follow up on the lecture we did the last time, lecture or unit 3. And what we are going to do is that we are going to learn two of the most important tools we can use to do program development. Okay. Specifically, we are going to look at what the program development is all about, what it entails, and then what an algorithm is. We're looking at key characteristics of a good algorithm or good algorithms, what they're supposed to be like. And then we'll look at why it is important to do algorithm design or program design. And then we'll look at those two tools. First being the pseudocode, which is a very simple tool I'm going to show you right now to do your program development. We'll run through some examples. Then, secondly, we'll look at flowcharts. Okay, it's also a very nice and very simple tool that is graphical in nature and can be used for program development. As the lecture goes on, you can share. Oh, you cannot hear me? Madam Millicent, can't you still hear me?
Please, I'm okay. I can hear now.
Okay, please give me a minute. Let me check. Hello? Hello?
Hello,
Hi,
sir. We
hi.
can hear you.
Hello, sir. We can hear you.
Yes, there's a student saying we can't hear, please. Can you hear me?
Please, I can hear you now.
Yes,
Thank you.
sir.
Okay. Okay. So as I was saying before, you can share your questions on what we are discussing on the chat so that I'll occasionally check it to make sure that and there are any questions shared over there, and then we can quickly go there and then attend to your questions. Okay. So first and foremost, as I explained last week, an algorithm is basically a sequence of what unambiguous steps, right? When we say something is unambiguous, it means that there is no doubt as to what the
Yes, sir.
meaning is. There's only one meaning. Hello?
Yeah. Well, Madina.
Sir, please, we
Hello?
can hear you. Hello, sir. Please, we can hear you.
Uh, oh,
Okay.
that's it.
I'll just ask that if it's not for a question, kindly turn down your microphones. I'm getting a little distracted by the many microphones, okay? Okay, thank you. Yeah, so an algorithm is basically a sequence of what unambiguous steps that are used to solve a computational problem. So, for example, we pick up a recipe book. When we pick up a recipe book for cooking, notice that in a recipe book for cooking, it gives you a set of instructions on how to specifically prepare a particular meal. And whoever you are, once you follow that recipe, you are going to prepare the meal the same way the people or the photos in the same way the photos in maybe the book are describing. At the end of the day, you should produce the same thing. And that is what an algorithm basically describes. Okay, an algorithm describes a sequence of unambiguous steps, step by step way to solve a problem. Basically, what happens is that in a computer system, we model programs to solve particular problems. So, for example, when we have a problem, we will write up a model of the solution. That model of the solution is our understanding of the way we want to solve the particular problem. Okay? Then, once we feed it some input, our understanding of the step-by-step way to solve the problem uses the input to produce a specific output or outcome. Okay? In a later course, I think in data structures and algorithms, you will understand why this algorithm is the foundations of computer science and programming. Okay? Now, when we write or when we have this idea, we need to write this idea into concrete steps. So basically, the algorithm is the concrete steps that we write up, but we can write in different ways. In fact, we are going to discuss the different ways. We can draw it in shapes, or we can write it as code, or we can write it out as plain English. Okay, so we can describe it in different ways. And so please have this at the back of your mind. Now, let's look at several examples of algorithms. So some examples of algorithms we have on our computer systems and in everyday life include searching. Okay, so in computers or on computers, on the internet, on your smartphones, in your applications, your apps you're always searching for something. Either you are searching for a friend on Facebook, or you are searching for a video on TikTok, or you are searching for answers to a question on Google. So searches or search algorithms are a typical example. A way, how do we tell the computer to search through a list of things? Some typical examples we can have include what? Linear search. So when the items we want to search are sequential, we use linear search. Another example is binary search. When the items you want to search can be arranged in a structure we call a binary tree, we use what we call divide and conquer. Okay? So it's a strategy we use in binary search. Then graph-based algorithms like Dijkstra, minimum spanning tree algorithms like Kruskal or Prims, graph traversal algorithms like depth first search or breadth first search are all ways we can go through items in a graph. Okay, so all of these are examples. Okay, but these are not the only examples of algorithms. Okay, so other examples of algorithms we can find in day-to-day life: sorting algorithms. Do we sort by brute force? Right? When we do that, we refer to that as what? Bubble sort. Okay. Do we sort it by what? Arranging in a deck. We call that what? Insertion sort. Do we sort by divide and conquer? We call that what? Merge sort. And then do we sort by quickly dividing the items up and using what we call pivot elements? We call that quick sort. So these are all examples of algorithms you find on your computer systems, okay? But of course, in real life, you can think of so many examples of ways problem can be solved, okay? These are all ways that, or these are all examples of classical or typical algorithms we have. Are we okay? Now, what are some of the characteristics? We can solve our problems in different ways, but some solutions are better than others. So how or what are the characteristics of a good algorithm or good solutions? Number one, it must be understood by everybody. Okay? It must be written to be simple enough, the language meaningful enough, and unambiguous enough that everybody can understand. Okay, so one of the key characteristics of good algorithms is that it must be unambiguous. Okay. Another key characteristic of a good algorithm is that you must structure it properly. Okay. You must write the steps well, line by line. What needs to be in line 1 should not be replaced by something from line 10. Okay. Because you can't do number 10 before you come and do number 1. You need to do number 1, then number 2, then number 3, so on and so forth. Okay, so a good algorithm should be well structured. You should take your time and think about what or how items should happen. The order in which items happen matters. Okay, now a good algorithm too must be mathematically sound. Okay, what we call that correctness of an algorithm. Okay, it must be mathematically sound. It must be written so that it will produce exactly the kind of results we want. So, for example, if we are looking for the algorithm to run and then generate maybe a sequence of random numbers, then it should not run and then afterwards generate people's names. Okay, that kind of thing. The algorithm should produce what we expect it to produce. Once it does that, we call it correctness, or it has satisfied the feature or the characteristic of what? Correctness. Another key algorithm characteristic, which is described as good, is what? Efficient or efficiency. What it simply means that the algorithm should not be one that consumes all the resources on the device. So examples of resources on your computers are what? Processing time. Okay, the processes cycles is very important. Another key resource is what? The memory, the amount of memory on the on the computer system. Okay, the algorithm should not be written so that when we try to run the algorithm, all our other apps cannot run, or it freezes everything and it consumes all the computational resources. No, it should be written to make efficient use of all those computational resources. Another key feature of a good algorithm is that it must be maintainable. When we say maintainable, what we mean is that you should be able to easily understand it and make changes, modify it when you want to, debug it or correct it if there are any errors. Okay, so I have a plan for cooking, and the cooking was such that I want to produce maybe fried plantain. But in this plan, somewhere along the line, there is maybe a cooking of the plantain in boiling water. Okay, you know that one will ruin the frying of the plantain. So it should be such that the plan should be such easily modifiable that once you realize that there's a problem and that you are not producing fried plantain, but you are producing cooked plantain, then you can easily correct that line, and then that correction will result in the frying of the plantain instead of the cooking of the plantain. I hope everybody understands. Okay, so it makes it, an algorithm should be so easily modifiable. Okay, then last but not the least, an algorithm should be such that you can scale it whether up or down. What we mean is that once the amount of information or data starts to grow, the algorithm should be able to handle or manage that amount or number of information. Okay, so these are some of the characteristics of a good algorithm, but there can be more than this. Okay, we can talk about so many other things aside this, but I think these ones are very relevant for our discussion and introduction to programming. So when we are writing algorithms, we should have these at the back of our mind, that our algorithms need to be written in simple language so everybody can understand it without misinterpreting it. It needs to be ordered so that statements follow after the other in a logical, well-structured manner. It needs to be correct mathematically. It needs to make efficient use of computer resources. It needs to be modifiable or maintainable, and we should be able to scale it up or down at will. Okay, so these are some of the characteristics. Now, there are many kinds or types of algorithms we find in computer systems. So I mentioned brute force. Okay, so brute force is when it's our sequence of algorithms where we try all possible solutions until we find a correct solution. So, for example, if I ask you to, I give you a basket filled with different color balls, and I ask you to find a strategy or an algorithm to sort the colors in the basket. Okay, one way you can do it is to pick all the balls one by one, arrange them, rearrange them, arrange them, rearrange them, arrange them, rearrange them until you come up with a sufficiently sorted basket. Okay, but you see, even though you find an answer, brute force or the idea is that you want to go through all possibilities. Or I give you my phone and I ask you to unlock the phone. Because you don't know my password, you can start trying every single combination of numbers on the phone to try and what? Break the password or to break the code. Okay, bro, that's what brute force does. Brute force goes through every single possibilities until we find the solution. Then another key algorithm we can see most of times is called recursion. So how recursion works is that recursion works by helping us to solve a problem by calling sub-problems of the bigger problem until we solve the big problem. Okay, so how basically I'm talking about is that, for example, I asked you to find the factorial of 7. Because you don't know the factorial of 7, what recursion will do or how we will solve the problem in recursion is that because we don't know the factorial of 7, we will try and find the factorial of 5. Sorry, of 6. Because we don't know the factorial of 6, we'll also go down and try and find the factorial of what? Of 5. Because we don't know that one too, we'll go down and find the factorial of 4, and go down to 3, and go down to 2, and go down to 1. We will go down until we find the factorial of something we know. And in factorial, we only know the factorial of 0. In fact, factorial of 0, everybody knows the factorial of 0 is 1. Okay. So because we now know the factorial of 0, which is 1, but we don't know the factorial of 7, we now come and multiply the factorial of 0, which is 1, by the factorial of what? 1, which we know. Okay, so we come from a place we know to a place we don't know. So we now, after finding factorial of 1, we come and now put the answer in the factorial of 2. Then after finding factorial of 2, come and put the answer in factorial of 3. Then factorial of 4. Then factorial of 5. Then factorial of 6. Then finally, we are able to find the factorial of 7. Okay, we call that type of approach recursive algorithms or recursive solutions. Okay, we can use it to do lots of different things. Okay, then another way we can solve problems, or another kind of or types of algorithms we can find on computer systems, is called divide and conquer. Now, when we have a sufficiently large problem that we want to solve, but we don't know the solution to the big problem, but we notice that if we keep dividing the big problem into half and trying to solve only half, we can find the solution to the smallest problem within that big problem. Okay, we call them sub-problems. So we keep dividing the problem into sub-problems until we reach a stage where we can solve the sub-problem. Then we will recombine the solutions of the sub-problem into the solution of the bigger problem. Okay, we call that divide and conquer. Okay, examples of such problem-solving algorithms are what? The merge sort and then the quick sort, which uses what? A pivot. Then there are problem or algorithm solutions which are also called the greedy algorithms. So basically what a greedy algorithm is that for a greedy algorithm, we try and find the local optimal solution. So if we have a problem and there could be more than one solution to the problem. But how a greedy algorithm works is that it tries to find the local optimal solution. When we say local optimal solution, what we mean is that it tries to find the most immediate, simplest solution to the problem. But that immediate solution could be one of the solutions where there can be more better solutions than that one. But because the algorithm is greedy, it always looks for the most immediate one. Once it finds one of them, it ends or it quits. Okay, we call that greedy algorithm, and we can find them in lots of places in computer science. Okay, then we can have algorithms for sorting. Okay, when we want to sort two things, we have algorithms for sorting. When you want to search or look for something, you have algorithms like binary search or linear search, depending on whether it is what? Sequential or it is in a binary tree structure. Then we can have what we call graph algorithms for solving shortest path based problems or minimum spanning tree problems. And then we have dynamic programming problems, okay, or algorithms. These ones try to break the program down. They work pretty much like recursion, but instead of calling ourselves on smaller versions of ourselves till we get to the one we can solve, here, once we know the answers to the smallest version, we don't call ourselves to that point. We call ourselves, or we call the sub-problems till we can find, by replacing the sub-problems with solutions to ones we already knew. So for example, if the sub-problem has overlapping sub-problems, then we just simply call ourselves on those ones. Okay, so I saw a couple of hands up. Who had a question or two? Are the hands down? Okay, Mr. Daniel Corley. Yeah.
Yes, sir. Good morning.
Morning, my dear friend.
And thank you. So with the algorithm you just explained, I wanted to know the difference between
Please, can you speak up a little bit?
Hello, can you hear me, please?
Now I can hear you.
Yeah, so I was saying that I wanted to know the difference between the recursion algorithm and divide and conquer.
Oh,
I'm a little bit confused over there.
Oh, they are very different. Like I said earlier, the divide and conquer, the problem is such that it's a very big problem you can't solve easily. So what we tend to do is to split the problem into half and see whether we can solve that problem. If we can't solve it, we split the half into half. We keep splitting the half into halves until we can solve that half. Okay. Now, once we have gotten the problem down to a point we can actually solve, we now recombine the solutions. But with recursive algorithms or with recursion, what happens is that the idea is that we don't know the answer, okay? But we know the answer to something called a base case. So in recursion, there's always something called a base case, which we know the answer to. So we find the strategy is to keep reducing the actual problem until we reach the base case, and then now substitute the answer or the subsequent answers in the actual problem to solve it. Okay, yeah. So I think you should there should be, or you should do a course like that in the future somewhere in your IT career. It's called data structures and algorithms. Okay, it's a very interesting and unique course. We can't do that course here right now, so I'm just giving you an intro to what algorithms are, the background of what they are, some types and those things, and then hopefully it will excite you enough to venture deeper into that. Okay, Mr. Ruben. Hello.
Morning, sir. Good morning, sir.
Morning, Mr. Ruben.
Sir, please, with the characteristics of good algorithms, I would like to know the difference between the unambiguous and the maintainability, sir.
Oh, like I said earlier, unambiguous means it has only one meaning. Okay. So if something is unambiguous, it has only one meaning. Okay.
And the maintainability.
Ambiguity means something that has more than one meaning. Okay. This one is very easy. And then the maintainability means like I said, you can modify it. If you can modify something, then it's maintainable. Or you can change it. Okay. Your algorithm should not be that it's so difficult people cannot understand, you cannot read, you yourself, you cannot even understand what you did or how the problem was solved. Okay. It should be easy enough to be maintained, to be modified, to be adjusted, something like that. Okay.
Okay, sir. Thank you.
And then we have a last. Hey, this is your name. Is it an actual name? There are so many signs in the name. Please, the person with that name, kindly.
Okay, sir. Can you please give another example for the recursive algorithm?
Algorithms, recursion. Oh,
Yeah,
we can find another
like
example.
another example. Yeah.
Oh, the core idea is what I described in the example with the factorial, but you can also use Fibonacci. If the thing is a series, like for example, the Fibonacci series, we can use recursion, or we can even use recursion in programming. Okay, sorry, we use recursion in programming. Sorry, so for example, if you write a function which calls itself on smaller versions of itself, then that kind or type of function is a recursive function. Okay, so yeah, I hope it helps.
Okay, sir.
Mr. Nathaniel, hello.
Hello,
Yeah.
sir. Hello, sir. Yeah. Earlier in our previous lectures, we talked about our, how do we call it, programming being in an abstract form. And over here, we are talking about it being unambiguous. Is it for
Hey,
other
hello.
Yeah, yes, sir.
Yes, just to maybe not get all your colleagues to be confused. Okay, we never said that programming is unambiguous. We are talking about algorithms, okay? And I am making specific mention of some of the characteristics of a good algorithm. I'm not referring to programming in general. I'm referring to algorithms. Please speak to the matter and do not. Some of your friends may not. I know in Ghana we loosely don't pay attention to the details, but the details are important, okay? Very, very important. We are talking about algorithms at the moment, we are talking about algorithms and not programming in general, okay? You can
Right.
go on, but please make specific mention to what we are talking about here.
Okay.
Yes.
I want to find if there's, how do we call it, You let me reframe the question and ask later during the class.
Okay. Okay, no problem. Okay, thank you. So, like we are saying, we are currently talking about algorithms. Okay, we're not talking about everything programming. Okay, there are lots of things we can talk about in programming with regards to what we said the last time is problem solving. We want to solve problems. There are many methodologies, many design strategies, and all those things. So all those areas are there. But currently, we are talking about algorithm design, types of algorithms, and some of the tools we can use to write algorithms. Okay. Thank you very much for your lovely questions. Okay. So how do we develop algorithms? Okay. Number one, we need to define. When somebody says define the problem, what it simply means that you need to understand the problem. So maybe we all know there's a problem, but what is the problem? So it must be defined in terms of the systematic problem. What it is? What is it? If it's a mathematical problem, what is it? What is the equation? If it's maybe generally a sorting problem, you want to move something, you want to do something, we need to know exactly, specifically what the problem is, the details or the specifications of the problem we are solving. Okay. Then number two, we need to know the inputs or list the inputs, the information you need. Once you understand the problem, you know that this is how the problem is, or this is what the problem is. Now, what information do you need to solve the problem? And what results would signify that the problem has been solved? So you need to know the inputs and the outputs. Okay? And once you know those things, how do we go from input to output? That is what we describe as the steps. Okay? So you describe the steps needed to convert or manipulate the input to the required outputs. Okay? So how do we manipulate the input so that we can get the output we are expecting? Okay? So that is what we describe as the steps. Okay, so the steps can be drawn or can be written. Okay, so take note of that. And then this is not the end. We need to test whether those steps has solved or have solved the problem. Okay, so we need to do testing at the end of the day. Right. So these are the steps or the method for developing an algorithm. So now let's tackle the first steps we use to develop the algorithm. Now, you often hear me say pseudocode. So basically, what is pseudocode? Okay, pseudocode is just a form of informal English-like language independent way of describing an algorithm or a program or the logic of a program. Okay, so usually instead of maybe you have the the inputs, the outputs, you want to describe how to convert the input and to output, but here we don't want to write an essay. Okay, we don't want to write an essay. So basically, what pseudocode provides us is a form of semi-formal. We don't also know any programming language, but we know English, which is just raw English text. Okay. So what we want to do in pseudocode design is to write phrase-like. Okay. So we write English phrases, right? Plain English phrases that describe how the algorithm should be written or describe the logic. Remember, the logic is the same as the algorithm. Okay? So please take note of that. Now, pseudocode provides us with what? Step-by-step verbal outline. So I believe most of us know what an outline is. Okay, an outline describes bullet points. Maybe, for example, you have maybe a very big book you are reading. as you are reading, you are summarizing pages of the book. You are providing yourself with an outline or a summary. That's basically what a pseudocode is. Pseudocode is like that summary or outline. You don't write it as a whole essay, but you write it in phrases which can be understood and written or interpreted to design your program. Okay, so that is what pseudocode basically is. Most times, pseudocode resembles actual code. In fact, if you know code, your pseudocode, because you are writing in English, it doesn't necessarily mean it doesn't look like code. Okay, but if you don't know code, you would write maybe English sentences, straightforward statements, one-line sentences, which are describing what you want to accomplish. Okay, but the more you know the code, the more you make your sentences more summarized, because code is not sentence-like. Okay. So let's go a bit further, okay? Now, what are some of the uses of pseudocode? So we can use pseudocode to describe how an algorithm should work. I think that's the most basic thing. Another thing we can use pseudocode to do is to illustrate where a particular construct, for example, where an if statement should be, where a loop should be, where a sequential statement should be, where a comment should be. Those things, we can use pseudocode to illustrate them so that you can better understand the technique or the idea or the rationale behind the algorithm. You can use pseudocode to explain the computing processes. Okay? So, for example, if you are presenting an idea or a program, the idea for a program to somebody who is not technical, you cannot take the code and go and show it to them and then try and explain the code to them. They wouldn't understand. But with pseudocode, they will understand because it is semi-formal, okay? And it's just in plain English. They can read the English the same way they read any other thing, okay? And then pseudocode also allows us to collaborate in a group when we are doing development, okay? So how do we write pseudocode? I have some of the tips, but it's not by force. There's no written rule. In fact, you can decide to ignore all of the things I've written and then do your own thing. Once we all can understand it, we are okay with it. But because we are doing a science, we need to provide a formal way of helping us to design things, okay? So number one, always capitalize the initial word. This is good. It helps you to know the start of every line, okay? But it's not a must. Please take note, it is not a must. It is good, but it is not a must, okay? Number two, make only one statement per line. This one is very important. In pseudocode, we write one statement, one line. The moment you start doing two or more statements, you are writing an essay. We don't do essay in programming. We just write the code line by line, okay? So pseudocode also takes after the same idea. Write the code line by line. Number three, you are supposed to what? Indent to show hierarchy. If you have a block of code, okay, if you have a block of code, and that block sits within another block, what the indentation does, that indentation allows us to understand that one block sits within another block. Okay, indentation allows us to understand that one block or the current block we are looking at, for example, over here in this example, you can see that this three, the two down here, sits inside the one up here. Okay, and all of this sits within each other. Okay, so use indentation to help you, people who are reading your code, understand the rationale and what sits inside what. Okay. Then number four, always end multi-line sections using any of the keywords end. So you can use end, you can use halt, you can use exit, right? Any synonym of end is fine. Okay. This one is used to end multi-line statements. Okay. Then number 5, keep your statements programming language independent. Okay, so because it's pseudocode, maybe if you know Java, you are tempted to put in the Java statements. Okay, but remember, people who are going to read that code don't understand Java. So the best thing you can do is just to use English. Okay, don't try and make it too programming language heavy. Okay, then number 6, right? Number 6, use the naming domain of the problem, not that of the implementation. So when you are naming things, for example, if you are solving simple interest, you should not be naming things like X, Y, and Z. But instead, you should be naming things like what? Principal, time, rate, okay? Those kinds of things are from the domain of the problem, not from the implementation standpoint, okay? Then the last but not the least is that you should keep the pseudocode simple and concise. You shouldn't be writing so many things to explain. No. Code, we don't explain ourselves, okay? We normally write comments to explain the code, but the actual code is straightforward. So when you're writing pseudocode, straightforward. Go straight to the point. Summarize it as much as possible. Concise, simple, and it must be able to be readable. Okay? Very, very important. Okay. So an example. I have 2 examples here. Number 1, this example adds 2 numbers. The first example adds 2 numbers. So how do we go about it? So you can see I'm beginning every word with capital. Okay, like I said, it's not a must, but it is advised. Okay. Then notice that there has a beginning and an end. Okay, or a start and an end. So that one tells us that, oh, our code is starting from here. Okay. Then look at something. The code is arranged because they are all in the same block. Their indentation is the same too. Okay. That's also very important. And you can understand that if I want to add 2 numbers, I need 3 variables. We spoke about variables. Okay. So I need 3 variables. I named the first one num1. I named the second one num2. Because of space, I didn't write the full word number. And then I named the third one sum. Then I ask the user to enter the first number, and then I collect the first number. Then I ask the user to enter the second number, and then I collect the second number. Then now I do the sum of the first and second numbers, and I put it inside the variable called sum. And now I am printing out the variable called sum. I already explained to you that I will use the word write to indicate what output. Okay, but you can use print, you can use what do you call it? Output, and so many other synonyms of the word write. Then I'll use input to represent what? When we are doing input into a variable, when you are collecting something and putting the thing into a variable, I will use the term input. So please remember that. Then now you've also learned that there's a term called begin. And once you begin, you have an end. And then when you want to create the variables, you use the word declare. Declare. Okay? So please take note of that, or those major things. In this second example, I'm calculating the area of a rectangle. Okay? Everybody knows what a rectangle is, right? So number 1, you have to understand the problem. So you have to know what a rectangle is. You know that if you want to find the area of a rectangle, you need 2 important things, the length and the width. Okay, so we begin the program. And then, of course, you declare the 3 variables, length, area, and the width. Then you create the prompts, statements that will ask the user for the value. Then you collect the value. Okay, so that's the value for length. Then another prompt for width, and then you collect the width. Okay, then you multiply length by the width. Okay, so it's done over here. And then the answer is put inside the variable called area. Okay, so area now contains the length times the width. Then you finally print the statement area is area, right? Area plus area. Okay, so this one, what it's going to do is I'm going to take this text area and then attach the number area to it. Okay, remember area contains a number because once you do length times width, you get an answer, and that answer is put inside the variable area. And so when you do area colon plus area, you will not see area, but you see area and then a number. Okay, so please take note of that. Mr. Nana Kwamana, your hand is up.
Yes, sir. Sir, please, my problem is the number 8. Okay. Thank you, sir. Sir, with the first example, adding 2 numbers. When we got to number 8, the right, it was answer plus sum. But with the second one, it's with the same number 8, it's area plus area. Why is it not answer plus area?
Okay, so let me go ahead and explain. It's because we created a variable called sum. We collected in example 1, we created a variable called sum. Look at the name of the variable. You see the name of the variable?
Yes, sir.
Then we collected the answer and put it inside sum. Okay. So the most obvious thing is that when we are printing it, we print what is inside sum. Do you agree?
Yes, I agree, sir.
Okay. So second example, we created a variable called area.
Okay.
You agree?
Yes, sir.
And then we collected the answer and put it inside area. Remember, we said that variables are containers. Okay. Yes, and sir. So the most logical solution is to print what is inside area. Hello?
Hello, sir. I'm here.
Yes. So you understand what I'm saying?
Yes, I understand.
So the name of the variable is what the name of the variable. If I had a different name over here, if the name was A, then it is A that I will put over here, and it is A that I will be printing out. Okay? So it's the name of the variable. You cannot create one variable and then use another variable elsewhere. Remember, the computer does not understand all of these things. What the computer understands is that you have created variables, you have done a computation, you want me to tell you the answer inside the variable. The computer can understand that one, but to think that the computer knows what area is or what sum is and those things, no, the computer is not self-aware, it's not self-conscious. Only you, the human being, understand what sum is. And you are the only one who attaches sentiment to what sum is. If you say sum, your mind goes to addition, right? But over here, sum is not meaning addition. Sum is just a name of a container. The computer only sees that SUM as the name of a container. So if you want me to show you what is inside the container, you must mention the name of the container, which is sum. So that's what the computer understands. It doesn't understand probably the sentiment you are attaching to the names.
Oh, okay. So say even in other words, with the first adding 2 numbers, the right, you can say sum plus sum, since you can say sum plus sum instead of answer plus sum.
Why would you say sum plus sum? You have taken 2 numbers, 2 different numbers. If you say sum plus sum, the computer will just add the same number twice.
Okay.
I said you are attaching too much sentiment to name It is just a name of a container. Whatever you name it is what the computer uses. If you name it X, Y, and Z, that is what the computer will use as the names.
Okay.
It's just a name. I've already described or discussed what a variable is. In the past,
Yes, sir.
I described in our last lecture, I think we talked about variables being a container, data types, and the rest. So I figured that probably you understand this at least a little bit. The computer does not attach any sentiment to whatever it is you are referring to the name. Okay? What the computer sees is that once you create the variable, it's a container. I can put something inside the variable. And once I put something inside the variable, if I need the thing back, I'll just have to type the name that I used. You cannot use another name. Once I create Sam, I cannot come here and now call X because I have not created any variable here called X. So I cannot say Sam plus X. Okay, sorry, answer quote plus X. Okay, it doesn't work like that. I need to use the name of the variable I created. Is it okay? Okay, there's another hand up. Evans, Anane, please make it short and concise, okay, so that we can go ahead.
Sir, please, is addition to what you just said. The line 7. So when the set sum equals this, you only bring the two numbers, but the answer won't be directly here. So the line A to
slow down. Go a bit slower so I can understand what you are saying. Okay.
Please, is addition to what you just said. So the line 7.
Well, which of the line 7? The first example or second example?
Either of them. I just want to clarify something for him to understand. Yeah. So when it says set sum equals, so the number from the line 2, line 4, and then line 6, you only enter the two numbers here because that's what the system will prompt you. Then the answer,
yes.
the answer
so for
will
example,
then come to
okay, yes.
Then the answer will then come to line 8. So that's what he doesn't understand.
Yeah. He doesn't understand. Yeah. And I think he's thinking that because we've called this thing Sam, that's what the computer thinks it is. No. The computer does not. It's just a container name. Okay, like I said, you can name it anything you want to name it, but the name must be legal. In our last lecture in the slides, I mentioned that variable names must follow the rules of programming. Okay, for naming variables, they must contain letters, uppercase and lowercase. They can contain underscore. They can contain $sign. They can contain numbers, but the name must not start with a number. So anything you name it with, we don't really care. Okay, the only thing we care about is that the data type and the variable name are correct. Okay, so once they are correct, you can put something inside, then you can use it in your programming. Okay, so for example, I'm writing some numbers as example. So for example, when I enter line 4 and I enter 2, and then it says enter second number, line 6, and I enter 3. So now wherever the computer sees number 1, it sees 2. Wherever the computer sees number 2, it sees 3. And so doing 2 plus 3 means that we are doing what? Doing num1 plus num2 means that we are doing what? 2 plus 3, which is 5. And so that answer 5 we put inside the container. So I keep insisting because I'm using that I'm using that term here. We don't normally say container. No, nobody will say, but I think in Ghana, when we say container, we understand. That's why I use that term. It helps my students to understand what the variable is. The variable is a container we use to hold things. The name you give to the container, the computer doesn't really mind the name. Okay, the most important thing is what is inside the container and and how it is being used. Okay, so this container now contains 5, and so whenever I call Sam, it will be 5. Okay, So that's basically what a variable is within the God's way. I said something bad, eh? God's way. Hello? You have to unmute yourself. Okay, God's way cannot respond. Otabel.
Yes, sir, good morning.
Yes, morning.
So what if you get an example of find the difference of two numbers? Find the difference of two numbers. And in the
Hello?
Hello, sir.
Have I gone offline? Hello? You
No,
suddenly
please.
stopped talking. I don't know why.
I heard someone also talking backwards. That's why.
Okay, it's not for
What
me.
if you get
It's one of your colleagues.
okay. What if you get an example like find the difference of two numbers? And in the naming of the variable, can you name it Sam?
Definitely yes. It's just a name.
Okay, thank you.
It's just a name. I thought you guys understood it, but I think you don't still get it. It's just a name. It doesn't mean anything to the computer. Okay? All the computer cares about is that the name is correct. You, the programmer, has to know what it is. That's all. But it's just a name. The computer doesn't care whether it's called sum or divide or multiply or whatever it is. It's just a name. But of course, if you name it sum and you are using it for subtraction, you yourself, you are confusing your own self. Okay. That's the only problem. Okay. You end
Hello,
up
sir.
confusing
Thank you.
yourself. Yeah.
Hello,
Thank you,
sir.
sir.
Who is this? Is it Nathaniel?
Yes, please. I believe their confusion is with the answer in quotation and the other side area in quotation. So they want to ask if you can put answer in quotation for the second example.
Okay. Oh no, why not? It's just so this one I mentioned when we talked about strings. Do you remember strings? Data type.
Yes, sir.
Yes. So yes. So you can when you are this whole thing is called concatenation. Okay. So what happens that when you are the computer, when you are writing a program, you need to remember the programs are written for other people, okay, and you will not be there when they are running the program. Just imagine that you just come on, you want to log into Facebook, and the person who designed Facebook just designed the login without putting the word username and password. So you just see two empty boxes, no instructions on it. Can you relate? Like there's a box and then there's a button there for submit. Okay, there's a button. There's no words on the button. There are two empty boxes. There are no words on the empty box on the boxes. You see, you'll be confused. You'll be like, but how the person create this thing without instructions? So this thing is an instruction. It just tells the person who is running the program that, oh, this is my answer. Okay, this answer is not a variable. This answer is a prompt. It's a string. It's just something that tells us that, oh, the number you are seeing after this statement is the answer. Okay, I could have just typed anything at all over here. It doesn't really make any difference. Okay, but last time when we spoke about data type, I mentioned this when we were talking about strings. I did say that strings are anything in quotes. They are printed directly. So you will see directly on the screen, you will see answer, the word answer. Okay. So you see answer. Okay. Remember, like I said, the computer doesn't really know the meaning of these things. It doesn't get the meaning of these things. Okay. So it's only you, the human beings who are reading it, who know the meaning. Okay. Huh. So something like this. So you see something like this on your screen. Okay. this thing is there. It's important. It's there so that you, the programmer, or the person who is using the program, you understand that the number which is following this thing is the answer. Okay. You can also write answer over here. Hello, who's that? Hello. Hello. Can you hear me?
Yes, sir. Yes,
We
yes,
can
sir. We
Yes,
hear
sir,
can
we
hear
you.
can
you.
hear you.
Yes, sir.
Okay, the person interrupting me all the time, please stop interrupting. Let me answer the question. I'll answer your question, but please let me answer a question and make sure everybody understands us. Okay. Okay. So this answer over here is just a statement we put. You can decide not to have it there. It doesn't matter. The person will only see 27. But what is 27? Okay, what is 27? Only you, the programmer, will understand that 27 is the addition of maybe one number and another number, and that's it. But if you put something here descriptive like this, it just helps. Okay? And then over here too, the person will see answer and then will see a number. Follow it. So the person will see area and then will see a number follow it. So the person understands that it's an area of something, at least. Okay, but you can also decide to remove this thing entirely and just write area. These two are quite different. You can see that they are different. This is not this. This is small a, R, E, A. This is not small a. Okay, yes, you are seeing area, but like I said to you, in programming, a spelling can make a difference. Okay, the way you put capitals can make a difference. This is a variable. This is clearly not a variable because of even the quotes around it. Okay, so the computer knows that this one is not a variable, but this one is a container or a variable. Okay, so they are different. Okay. There was a hand up, and then I think let me just answer the question in the chat. It says what? Sir, please, so with pseudocode, the steps listed are always the same. The only thing is to make sure to end, what is end declare? Okay, I don't understand what you mean by end declare, Mr. Hakim.
I think it's end, as in AND.
To make sure AND, as in to make sure and declare. Okay, so come again, Mr. Hakim. I don't understand what you're saying. But basically, if you remember, last week, we learned about the program development framework. Okay, so that even answers your question. So when you have a problem, you go through the program development framework. Now, if you look closely, notice that from line 1 all the way to line 6, I think, deals with what? Input. So before you can do input, you must declare. So you always declare, you do input. Then line 7 deals with what? Processing. Okay. Then line 8, the last one, deals with what? Output. Is that not the case? Are you not seeing it?
Yeah,
Yes,
we are
sir.
seeing it.
Yes, sir.
Yes.
Uh,
So it's
I
the same
understand.
thing we discussed. The same thing we discussed last time. But I think some of you are not reading the material very well. Okay. Same thing we discussed the last time. It's not nothing different. Okay. This is a practical. So you see, from line 2 all the way to line 6 is input. Before you can do input, you have to declare. So we do the declaration, the input, then line 7 does the processing. You can see processing. We are doing the computation. Then line 8 does the output. Okay, so please follow along. All the parts of the course or the material connects together. It's the same idea. The idea is pretty much the same, but we can use that simple idea to solve different problems. Okay. Okay, that's a question. Is there a question? I've answered your question. Okay, thank you. But your sentence was not understandable, so don't worry. Okay, thank you. Okay, so these are examples of another example of pseudocode. Okay, another example in this example, we want to find the average of 4 numbers. So let's think through the input. So if you want to find the average of 4 numbers, you need 4 numbers. Okay, you need 4 numbers. So we create 4 numbers. Okay, we create 4 containers. Sorry. Okay. Then we need to how do we find the average? We need to add all the 4, divide by the sum of the 4. Are we okay? So we need to add all the 4, divide by the sum of the 4. Okay. Then so to get the 4 numbers, we do the input. So we do a prompt, and then we collect the 4 numbers. So you can collect all 4 numbers at a go. Okay. So this one, because all 4 are numbers, just integer numbers, we just separate them with comma, 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 comma. Okay. I think we are missing a line or two. Let me do a correction here. Let me do a correction here. Okay. So we declare. So we declare an integer variable with a sum, and then let's declare AVG at the average. Okay. So we can use it in our computation. Okay. 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 So we create the numbers, and then we create other numbers. Okay, other containers. We collect all the numbers, and then we add them together. And once we are done adding them together, we divide them by the number of numbers. So average of 4 numbers is the sum of the numbers divided by 4. And so now we have the results. You can write average, you can write results, you can write whatever it is you want to write. Okay, this one is not important. The most important thing is that we are printing the answer. Okay. Then here to second example, the area and circumference. So notice that we have to find 2 important things. The area is there, and also have to find the circumference. Okay. So please note, we are finding 2 important things. Okay. So in order to find the area, what are your inputs? You need the radius, because it's pi r squared. Okay. You remember, area of a circle is what? Pi r squared. So you need the, remember, pi is not something you will collect, because pi is always going to be what? 3.141 something, okay? And then, so you create the variables, you create radius, you create a variable called area. Remember, it's just a name. You can call it whatever you want to call it, okay? But when I was suggesting to you, I suggested that you use names which are from the problem domain. So that's the reason why you can see me use radius. The fact that I've used radius doesn't mean the computer understands that that variable is radius. Only I am the one who understands that that variable I'm going to use to hold the radius of the circle. Okay, so please be following that along. Okay, then the next one, a variable called area, and then a constant variable called pi, and then a variable called curriculum. Okay, circum or circumference. Okay, I shortened the name because it couldn't go here. Okay, then the inputs, the only input I need is the radius. Okay, so I collect the radius from the user. I create a prompt, enter the radius, and then I collect the radius from the user. Then I set the pi to what? 22/7 or 3.1412, blah, 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 blah. Okay. Then when I'm done, I do the processing are two steps. Okay. So processing are 2. So what am I doing in processing? Number 1, I am what? Calculating the area, which is what? Pi times radius times radius. Remember, r squared is just r times r. Okay. Then circumference is equal to what? 2 pi r. So 2 pi 2 times pi times r. Okay, so that's what you notice that I didn't write 2 pi, okay, because I've already told you that in programming you have to write what is happening between 2 and the pi. So you have to write that 2 is multiplying the pi, okay? So you have to write all of the mathematical expression in full. So 2 star pi star radius, okay? Then here, notice that the output is also 2. There's first one up here, line 8 and line 9 are output statements. And of course, don't forget that once we do a start, we have to do an end over here. Okay. So have you seen that the whole thing is very interesting and very, very, very wonderful? It's very simple too. Very, very simple. Okay.
Yeah.
Now let's forge ahead. Let's forge ahead and then now look at another tool. So the next tool is called flowchart. Okay, you think that pseudocode is even simpler. Flowchart, you will even be surprised. Okay, so flowchart is also another powerful tool we can use to represent computer algorithms. Okay, flowchart is a what do you call it? A diagrammatic tool. It means that we use diagrams to represent that instead of writing in English statements, we draw a particular shape to represent the flow of control or flow of execution. Okay, so let me. The purpose of flowchart is to help us visualize. Okay, so usually flowchart will be used for visualization, to design and to communicate. Some people prefer diagrams more than writing. Okay, so that is why or how flowchart is important. Oh, somebody's asking a question about the data type. Which one are you talking about? Mr. Felix, which one are you talking about?
The area and circumference, please.
And because they can be decimals. We already talked about this the last time, right? Data types. Float is for decimals. It means I'm expecting that if you multiply something by 3.141, you notice that pi is 3.141, right? So there's no way you can say int. Okay.
Okay.
Yeah, pi is not an integer, so you cannot put an int. Okay, so the correct thing is to put it in a decimal, which is a float.
Okay, sir.
Yeah, we've already talked about this, so it's in your notes. It's in your notes.
Yeah, I understand, but I saw radius area. That is why I was asking why was
Yeah,
it
so they are also going to be decimals because I'm expecting that radius is not necessarily going to be an integer all the time, right? You can do 2.5, you can do 2.1, you can do 3. You can do any decimal. It's possible. And then area is also going to be a decimal because once you are multiplying a decimal by something, you are going to get a decimal. So you cannot put that decimal inside a whole number. I told you the computer only understands int as a whole number. So you cannot make area an integer when the rest of the things are decimals.
Okay, sir.
It is possible.
Thank
you're
you.
welcome. You're welcome. And Michael. Mr. Michael. Okay, Mr. Isaac.
Hello, sir. Good morning.
Yes, sir. Sorry. So this is Michael. Please, the pi is also constant. So please, why didn't you use the constant, but you use the float?
Oh, constant is not a data type. Constant is just to tell the computer that I don't want anybody to change the value. Okay? So if I have a number that I don't want people to change the value, it is a constant, but it is still a number. So you have to tell the computer, oh, it's a number, but don't make people change the value.
Oh, okay.
Right?
Yes, sir.
You understand the idea is that tell the computer the data type. As for the data type, you cannot ignore, you cannot avoid it. You have to always tell the computer the data type. Yeah, it's important. Okay, so you must always tell the computer the data type. In addition to telling it whether it's a constant or not. Those things are also important. Okay.
Okay.
There was a second hand. Is the person gone? Okay.
Areas and circumference like this. So
Pardon? Okay.
Please, the data will be given in the question, or you have to provide your data.
The what? The what?
Like calling the areas and circumference of a circle. For you to call like the radius, the areas, and pi, they'll be giving you in the question.
I don't get you very well. What do you mean by they'll be given? What are you referring to?
The question.
The question. Well, I've not so far done any questions yet with you.
Area and the circumference of a circle. Yes.
No. Okay, so if I understand you correctly, you're asking whether the number for the area or something will be given?
Yes, please. Yes, please.
No. We are basically not interested in the number, okay? It's not of importance to us. What we are interested in is the program you are writing to collect those numbers. Okay, your program must be generic enough that whatever the number the user enters, your computer will still generate an answer. Okay, so this one is not like mathematics where we need the numbers or we need the answers. Okay, this one is programming. When, for example, when you go and try, I think all of you have Facebook accounts. Okay, now when you go and try and log into your Facebook account, okay, you notice that you enter your password, your username and password, okay, and then you log in. Another person goes, enters their username and password, it still works. No matter the person who goes, it will work. You can keep changing username and password, it will still work. That is what we want your program to behave like. No matter the data you give it, it must still work. So we don't write the program with numbers in it, no. If you write the program with numbers in it, it will only work for that number. Then what happens if somebody wants to enter another number? We want you to understand the program for what it can do, okay? For the processes, okay? Input, collect input, process the input, produce output, that kind of thing. But not necessarily that, oh, if I area is radius is 2. Okay, then that does not help anybody in the programming. Okay, your programs would not be really good if you are only focusing on the number.
Okay. Thank
you.
Sir.
So understand the rationale. Okay, follow me on the rationale. I know it's hard, a little bit different from what you are used to, the way you are used to thinking, but this is how programming works. Okay, and you need to understand it for the next course, not only for the next course, even, but for the exams at the end of the period. Okay, so try and follow me one step at a time. Okay.
Copy, sir. Okay.
It's hard. Change the way the thinking is. Change the way the thinking is. So don't think about the numbers. Don't think about the numbers. Focus on the algorithm, the formal process, step by step, input, process, and output, those kinds of things. Focus on that one and not the algorithm, not the numbers. Okay.
Thank you, sir.
Okay. Okay, so let me just skip all of those. These ones you can read over here. Okay, these ones, they are very easy to read. So I'm going to skip them. Now, let me introduce to you a couple of figures or diagrams for flowcharts. So flowcharts, we can have a start and an end. We call them the terminators. Okay, we use what we call an oval or rounded rectangle. In flowchart, you can often see the arrows. We use the arrows for the flow of control. In fact, your flowchart will be incorrect if there are no arrows. Okay, so your flowchart must always have arrows indicating the flow of control. Okay, then for processing, you must always use rectangles. Okay. Then whenever you are doing input or representing output, you must use what we call a parallelogram. A parallelogram is a slanted rectangle. Okay, it's a rectangle, but it's slanted. Okay. Then for conditional statements like if statements or else statements, if else statements or loop statements or switch case statements, we use the diamond. Okay, the diamond. So I have the shapes over here. You can see the start and the end. We call it a terminator. So begin and end, we can use this shape. Then where the flow is flowing, we use the arrows with a line. Then if you want to do input and output, we use the parallelogram. Then the processing, we use the rectangle itself. Then decision, we use the kite or the diamond. Okay, so let's look at some examples. So first example, very simple program. So in order to help us understand it better, I have the program written in pseudocode on the left, and then I have the program drawn in flowchart on the right, so that you can compare side by side. Okay, but I will explain the one on the right more because this part is focusing on flowchart. Okay, and I have intentionally colored them differently so that you can easily identify the different shapes. Okay, so we know that number one is the terminator, the start. Number two, we create the variables, so it's a process. Okay, creating of the variables is a process. Number three, we collect the inputs. Okay, so it's a parallelogram. Okay, in yellow. Then number four, we do the computation or the processing. Okay, after the input, we do the processing. Okay, so that one too is a process. Then number five, we do the output, which is what? A print statement. So that one too is a parallelogram. Okay, then we finally end the computer program with what? The oval shape or the rounded rectangle. So notice that every line in a flowchart must correspond to a line in what? Pseudocode. So you can actually look at a pseudocode and translate it into flowchart. It's very easy. Okay? It's very, very easy. The start is an oval. Declare is a process. Okay? Input is parallelogram. Set is a process. Write is a parallelogram. And then end is what? A rounded rectangle or an oval. Okay, so notice that every line corresponds to one of these over here. Okay. Any questions about this simple example? I have several examples. Okay, I have several examples. Any questions? Yes, Mr. Otabel.
Yes, sir. So please, with the flowchart symbols, can we represent it with our daily life activities, things that we do in our daily life activities? Can we draw flowcharts to represent them?
Oh, yeah. Why not? Yeah.
Okay, so please, can we try one? One example.
No, I'm doing programming. How can I just do an example of daily life activity? I'm doing programming.
Oh, okay.
Yes, let me teach programming. And you can, after understanding, you can go and then do daily life activity flowchart. That's fine with you. But let me just do programming, okay? Because the meeting is being recorded and it's about programming, structured programming. Okay, so I can do an example. I'm going to do several examples in programming for you. Okay, because the course is about programming. Okay. Yeah.
Okay. Thank you.
But once you understand, you can go and do the daily life flowchart you want to understand it with. Okay.
All right.
Yeah. Mr. Nana.
Yes, sir. Thank you. Sir, please, with the diamond, you said, can we go back small?
Yeah, I'll let me clear this.
One.
Yeah, the kite or the diamond, yes.
Yes, it's the decision, but in this example, we didn't see the decision, which
Oh
is the
yeah, because
diamond
there's
sign.
no
When
decision.
you
It's not because, listen, it's not because we said we have to have a process or we have to have inputs. So every time there's input. No, some programs don't have. Every program has a particular thing. You know, this program is very simple. There's no decision here. If I ask you to if I ask you to double my money, do you need to make a decision? No, you just need to collect the ask me how much money, collect the money, double it, and give it back to me. Isn't that what you do?
Yes, sir.
So that's the idea behind this. So declare the variable, collect the number, multiply or double the number, give it back to the user, and end the program. So there's no decision here. But you will see it very soon. Okay, we are going to do if statements, I think, in our next lecture or so. So very soon you encounter it. Okay.
Right. Yeah.
Yeah. Okay. Another example. So in this example, we are adding two numbers. Okay. It's the same program from the pseudocode. Okay. We're adding two numbers. Okay. So I just brought up the program, same program. So now what are we doing? We declare variable num1 for the first number, variable num2, second number, and then variable sum. Okay. So this is a process. Okay. This process. And then, of course, don't forget the stats. Then we write. Okay. This is a prompt. Enter first number. We input. Collect the number. We write. Enter second number. Then we input. Notice that write, input, based on what we have learned earlier, input and write are represented with what? Parallelogram. Now, if they follow each other like this, all together like this, you can decide to draw them all on one shape. And then write the instructions on the shape. So here I decided that since we have write input, or input, output like that, I'll just draw everything on one shape so that it makes it very simple. So you can see one shape and then all the input, write, input, and then write input on it, right? So it's very simple, makes it very easy for you. And notice, please, I forgot to tell you in the first example, but notice the arrows. You see the arrows? They are very important, okay? They tell us where we are going. From here, we go here. From here, we go here. At this point, the arrows are telling us that we are going what? Down, okay? Then what else? So we do what we call set. So I said set is processing because we are doing a computation. So we do rectangle, okay? We write or we draw the rectangle. Then we write the thing on the rectangle. Then write is output. And we learned that output is what? Parallelogram. So we do parallelogram, okay? Parallelogram, right? Then at the end of the day, we do an end, okay? We do an end. So notice that this is representing this program over here, very simple program. Nana Kwabena.
Yes, sir. Sir, with a small arrow connecting the box, since you said it's very important. Okay, from the green to the yellow, the arrow is slanted a little bit. Does it draw any concern?
Oh, no. Remember, I'm drawing these things with tools. I didn't draw it by hand though. I drew it in Microsoft PowerPoint. Okay, so let me show you something. So you see, as I move it, you see it moves. It's just my hand not being still enough to correct the thing. That's all. It's not anything. Okay, please don't.
Right.
Don't. You are. I know you're
No,
interested.
since you said it's important, I was paying close attention.
Yeah, the arrows. I mean that students have a habit of not remember. Some people don't even put any lines in between. They just draw the boxes and then leave the thing for me. And I'm indicating that you have to remember that the boxes alone is not flowchart. It is the arrows that tell us where the flow of control is happening. Okay, so you must put arrows on the lines. Okay, that's what I'm trying to tell you, not to have you. Yeah. Okay, next example, area of a rectangle. That one too from the first pseudocode example. Okay, so I have the same pseudocode here, and then I have the flow chart representing the pseudocode. Okay, so make it very easy for us. Once you understand the flow chart, the pseudocode, it's just a matter of mapping the flow chart to the pseudocode. Okay, so begin over, okay, end also over, okay. Then declare is a process, okay. So declare is a process. Then, hey, who is that? Vincent, please stop that, okay. Then input, output, all parallelogram, okay. So you can write it all on one sheet, okay. Then process set, or the calculation is a process, so you put it on set, and then the write is output, so you put it on a parallelogram, or yeah, that's it. Okay, so here too, there's the flow chart for that example. You see, it's very simple, very simple shapes to represent procedural programs. Mr. Godwin.
Yes,
Mr.
sir.
Godwin?
Good morning, sir.
Morning, sir.
Yes, sir, please, I want to make reference to the arrows. So will there be an instance that you can turn it upside down and change the direction of the arrows, or it's advisable to go in this direction?
You want to turn it upside down?
Like you
But why
start
would you want
with
to turn it upside down?
Yeah, I think you make reference to the where the arrows are pointing. So I want to know if you can just change the direction and point the arrows upward instead.
Yeah, but you see, when you start, you must go towards end. I don't know why you would end and then go towards start.
You start. I'm asking if you can start and move it upward.
Oh, yeah. Why not? Why not? If you want to do that, that's fine.
Oh, okay. That's
Yeah, but
what I
you must
wanted to
move
ask.
in a logically correct way. So I think you can move sideways, you can move up, you can move down, you can move left or right. That's fine. Are you okay? Mr. Godwin, are you
So it all
okay?
depends on the direction of the arrows.
Yes, it depends. We assess it based on the direction of the arrows. And your arrows,
All right, sir.
once you start, you must always end up at an end eventually.
Yes, sir. Thank you, sir.
Yeah. Yeah. Oh, next person. There was a hand up from. Hello, next person.
Good morning, sir. Hello, sir.
Yes, sir.
Hello.
I'm here, sir.
Sir, you said with the flow charts, the declare int. What was the full declare? What was the full meaning? Int length.
Declare int. Int is int.
Okay. I thought maybe it's a full word and maybe you've abbreviated it.
I have not. That's how we write int.
Oh, okay.
Declare int.
Integer.
It's a full word. It's
Yes,
a full word.
int
You
for
write
integer.
Is it your first time in class?
No, sir.
Hey, I'm actually shocked. Okay, so int is a variable. It's a data type. We have talked about data types in our last lecture. I think you can check the video they posted. Okay, in the LMS. Int is a data type. Okay, it represents integer. It means that the variable can contain a whole number. Okay, if the variable does not contain a decimal, then we call it integer or int.
Thanks, sir. I'm okay.
Pardon? Okay. Portia.
Yes, sir. Good morning, sir.
Morning, madam.
Sir, please, I wanted to clarify something. I wanted to know if write and input is the same as see out and seeing in.
Yes, please. Yes. So you are very correct. Okay.
Okay.
In C++, if you want to write, you do see out. If you want to read or collect something, you do see in.
Seeing.
Yes. But that
Okay.
is C++. We are not at C++ yet. Okay.
Okay,
So
sir.
for us over here, we'll just do write and input. Okay.
Okay, sir.
And I
Okay.
said, like I said earlier, it's pseudocode. You can write whatever suits you. Okay.
Okay,
But
sir.
the
Thank you,
advice
sir.
I gave earlier, don't make it too programming. Okay, else it's a programming. It's not. Sorry, don't make it too language specific. Okay, else it's language specific and it's not pseudocode.
Okay, sir. Thank you.
You're welcome. Yeah. So I think let's see. Yeah. Okay. There's no question. Yes, Mr. Emmanuel, I was surprised. Weren't you also surprised? Mr. Emmanuel, I was surprised the gentleman didn't know what int was. It's perfectly normal, okay? Yeah. Okay, another example. So in this example, we have the pseudocode on the right, the left as always. So start, you draw the shape for start, which is an oval or a rounded rectangle. The shape for the declare. So we have two declares, okay? So the shape for the declare is rectangle. Okay, let me do a correction. Small, okay. Think we need another declare. Forgot to put that in there. Some, AVG. Okay. Okay. I think that solves the problem. Okay. Okay, so now we have all the declare statements there. So the declare, if they follow each other, like I was doing earlier, if they follow each other and they are the same shape, you can draw the shape bigger and write them on each other, okay? So the declare, the right input, they are all parallelograms. The set, they are all process, and so rectangles. The right, they are all what? Parallelogram. And then the end. Okay, so I noticed that some students, I don't know whether they are confused about what a parallelogram is or they want to just trick me. Sometimes they draw a rectangle and then they put some lines in the rectangle. And then they leave it to me to decide whether they are drawing a rectangle or they are drawing a parallelogram. So some students will draw this, okay, rectangle, and then they will draw some lines like this inside. And so, and then they'll write their thing they want to write, okay? Now notice that they want me to decide whether it's a rectangle or it's a parallelogram. Unfortunately, going forward, I will not be accepting something like this, okay? So please, when you are drawing, if it's a rectangle, draw a rectangle. If it's a parallelogram, draw the parallelogram, okay? You see, when we ask you to draw a flow chart, even though it's very simple, the marks comes from the shapes, okay? So if you have to draw a parallelogram and you draw a rectangle instead, you are wrong, okay? And that's basically it. Once you are asked to draw something and you have to do the drawing and you draw the wrong shapes, I'm afraid you'll be wrong. Okay, so please take note of that. The shapes are not many, they are just 4 shapes. The diamond, the parallelogram, the rounded rectangle or the oval, and then the rectangle. Okay, so please take note of them and then use them appropriately. Okay. Then another example, or the final example, I have the area and circumference of a circle. Okay, so here we declare the 4 variables, one for area, one for radius, one for pi, and one for circumference. Okay, so the 4 variables declared over here. And then remember, variable declaration is a process, so rectangle, and then write and input parallelogram, so input, output, and then the rest of them process. So we set the process, and then the write is parallelogram, and so we draw up the parallelogram. Okay. Any questions? And then we call it a close. Any questions? Are there any questions, please? Can you hear me? First and foremost, can you hear me?
Yes, please, we can hear you.
Yes, sir, we can hear you.
We can hear
Are there
you.
any questions, please? Okay, Mr. Nathaniel.
Yes, sir.
Yes.
With the question I was asking earlier, I am clear with it now. During your explanation of brute force, the line kept breaking. And when you also got to the other one, which says sorting.
Hello.
The line was breaking, so I was finding it difficult hearing what you were saying there.
Okay, so you just want me to explain brute force?
Yeah.
Oh, brute force is when you go through all possible solutions. Okay, so for example, I said that if I give you my phone and I ask you to enter my password or enter my PIN, okay, and you start entering every single combination of number to try and break into the phone, and that is called brute force. You don't know, but you want to see if any of the things you are entering will enter. Okay, will allow you to enter into the phone. Okay, so that's an example. And then you said, well, sorting. Sorting is when you arrange things in a particular order. So if I have numbers 1, 2, 3, 4, 5, 6, 7, 10, but they are not in an order, and I ask you to organize it in ascending order, you do 1, 2, 3, 4, 5 from the smallest to the largest. If I ask you to arrange in descending order, you do 10, 9, like that to 1. Okay, so that's basically it. Same thing we know already. Okay.
All right, sir. Thank you.
Welcome. There's a hand. Okay, Solomon Nete.
Sir, thank you. I don't know, this morning your network is not helping. Sometimes, I don't know what is happening. I thought it was coming from my end, or I was experiencing it only. That is only the problem I have. Thank you.
Okay. Thank you for bringing that to my attention. Nathaniel, you have a question again?
Good morning, sir.
Yes, good morning.
Sir, it happens that the Nathaniels are two, so I'm not the one who answered the first
okay,
one.
okay, no problem. Sorry.
So, sir, from your last example, you see, from the start, then you came to the input, declare fruit, radius, pi, and you see, after the second, the radius input radius, enter the radius. We have the rectangle following 3 times, set pi, set radius, and set circumference. Is it possible you can put all in one big rectangle, but because they are all like process in my understanding?
Yes, you can.
Okay.
I'm just showing you that there's no one way of doing things. You can do things any way you want to do it, provided it's correct.
Okay, sir.
In the earlier examples, I had them in one. I had multiple right statements in one. Okay. But in this example, I decided, let me show you that you can do multiple of them. So it's not anything. Okay.
Okay, sir. Thank you, sir.
Mr. Vincent.
Yes, sir. Good morning, sir.
Morning, sir.
Sir, please, when you take a close look at these ones, you see the first one.
Hold on. When I take a close look at what?
The flow chart.
Yes.
The first one, round square, no? Which is the start?
Hey, hello. Which one is the round square? Okay, the rounded rectangle. It's not a square. Oh. Hey.
Rectangle, sorry, sir.
Hey.
Sorry, sir. So you see, it's matched with the end.
Yes.
And also the rectangle, the green one, the declare with
Yes.
this, it's also matched.
It doesn't match with anything. Please, they are not meant to match. Okay. They are not meant to match. I think I get what you want to ask. You want to ask whether they must match?
Yeah.
No, come on. You are building a program. You are doing input, processing, output. There's no way input will match processing, okay? Or there's no way processing will match output. No. You are building a program. Just you have the logic or the understanding of how the program should work. So you first do this, first do that, then do this, then do that. So you draw it based on your understanding. Don't draw it because they must match. No. The start and the end, they match because whenever you start something, you must end something. That's all. That's all I have to say about that one.
Okay, sir.
Yes. Aside the start and the end, which are the same, but even they are not even the same because that is start and this one is end. They are not the same. Just that they have the same shape, or because you are seeing the color red, you think they should have. No, they don't have to be that way. Okay. That's not what I thought. Yeah.
I mean the shapes, sir.
Yeah, and I'm saying that the shapes don't have to match. No. They don't have to match. They should follow the logic of your program. It's about the logic, not about the shapes matching.
Okay.
Yeah. Else, I would have said that they have to be symmetric. Okay. Symmetric means that once you have a left, you have to have the right, or once something starts, it must end. No, that's not how it works.
Okay, sir.
Okay. So Solomon Nete.
Sir, thank you for your time. Please,
Welcome, sir.
I want to ask whether this live has been uploaded on our platform, the LMS.
Oh, yes.
All right. Thank you, sir.
You're welcome, sir. Okay. There's no other question? Vincent, your hand is still up.
Sorry, sir.
Okay. If there's no other question, then we'll call it a day. And then thank you so much for Madam Portia.
Yes, sir. Sir, I want to understand flowchart and pseudocodes. They just aid us in writing the steps in solving a problem before the actual program.
Give me.
Pardon?
Mommy is calling me. That's me.
Oh, who is that? Portia, you said come again, not the part with not the actual program. I didn't hear that well.
So I'm saying that the pseudocode and the flowchart, they aid us in writing the steps in solving the problem before we go to the programming itself using either C++ or Python, etc.
Yes.
Okay.
Yeah. That's basically what they do. They just the tools you can use. Okay.
Yes, sir. Yes.
Yeah. And Felix.
Yes, sir. Good morning.
Morning.
So please, I want to ask if the flowchart, if it's fully like mathematically based programming, or it can be used for other, like solving other logical problems and stuff.
Oh yeah, but we've not done any mathematics. Have we done any mathematics? Okay. My examples are mostly mathematical because that is how basically I remember the examples are coming from me. So the only thing I know is maths. Okay, that's why they are like that. Okay, but you can use it to solve any other programming problem. That is structural. Okay, structured programming you can use to solve any problem.
All right, thank you, sir.
Mr. Michael, please very quickly.
Yeah. So please, someone said round square. Please, which one is the round square?
Someone said what square?
I heard someone asking a question about round square. I want to know which one is the round square.
Round square. Someone asked a question about round square.
Rounded
I
rectangle.
I don't remember what.
Hello,
I
sir.
don't
Well,
know the question about round
actually,
square.
the person meant
He's
to
talking
say
about the sheeps. The sheep.
Oh,
The
talking
sheep.
Said
about
it's a mistake.
the start and the end. That someone said the
Oh, they said round square. Okay. I
Said
think it's
said
this one.
person
Oval.
corrected it
Oval.
already.
Yes.
Mistake.
Oval. It's either a rounded rectangle or an oval.
Yup.
Okay. Yes. Solomon Nete, your hand is still up. Oh. I
Oh,
thought
okay, okay.
okay, I think the guy is not here again. Okay. So thank you very much for the time. See you God willing. I will send you the assignments which you finish in groups of 2 people each and then submit when we meet for our face-to-face. Okay, so the course rep will gather everything. I don't want them typed. Okay. You go and
Yeah,
type them
please.
from, you go and just copy them from ChatGPT and come and paste them in a Word document and type it or print it. No. I don't want them like that. So please take note of when you are submitting the assignment. They need to be properly written on a foolscap sheet of paper with the 2 people, your names and your index numbers. Okay?
Okay.
Yeah.
Sir,
Michael,
sir,
another
please.
question again.
Sir,
Michael.
sir, please. Last question. I don't know. They have created groups for us so that maybe, it will help us with research and doing project and the stuff.
What is the question?
So in numbers. So with the 2, I don't know, but I don't know. Thank you, sir.
that would be the responsibility of the class rep who are going ahead of things.
I didn't hear any question. No. I only heard him saying something and then he went off. Okay. So Mr. Nati, you have a question? Okay. Mr. Nati, please, it's time. Okay, thank you very much. Thank you.
Thank you, sir.
Have a nice weekend.
Thank you. Thank you.
All right. Thank you, guys. Thank you, Chief. It was awesome session. Okay, so we have a next section. I'm sure we'll use the same link. We'll use the same link. So let's see. Now, teach lecturers from ChatGPT now. Open our channel there. I beg you. All right, please. Let's check our schedule and see our next class and
Guys, wait, let's go.
Yahoo.